Hello everyone, welcome back. In this session, I want to talk about optimization. I want to tell you how to optimize your model to get better results. Today, I want to tell you about gradient descent, the most common algorithm that can optimize your model. But before we start, let me review some points from previous session for you. As you remember, we had this formula for our hypothesis function. And I told you that we need to minimize our cost function if we want to have a high accuracy classifier. And also I told you that if we want to minimize our cost function, we have to find sets of parameters like theta 0 and theta 1 somehow to minimize our cost function. Before we start to talk about gradient descent, let's review some points. This is a parabola diagram, and you can see that it has just one minimum. Imagine you are here and you want to get to the bottom. So we start to go down step by step. And as you can see, at first the slope of the line is high, and by the time it is decreasing. Therefore, our steps are getting smaller and smaller each time. And finally, at the bottom point, the slope is equal to 0. Now it's time to talk about the most important part and aspect of machine learning and deep learning: optimization. In optimization, we can use some methods. The most common method is gradient descent. You can use gradient descent algorithm for different problems, but right now we're talking about linear regression. What gradient descent does is that it will evaluate your parameters, theta 0 and theta 1. Then it will compute your loss, and after that, it will take a small step in a direction that can minimize your cost function. You can see gradient descent formula for linear regression problem. And don't worry about some parameters that you don't know, like alpha. I will talk about it later. So the landscape of loss for linear regression is always going to be a bowl-shaped function. In other words, it's a convex function that has no local optimum except the one global one. We can have too many local minimums, but they are not the one that we are looking for. We are looking for the global minimum. But the good news is that in linear regression, we have just one minimum. So why don't we just directly jump to the global minimum? The truth is that loss landscape is invisible for us. And what I just shown you is because of helping you to understand and learn better. So what should we do? Let's pretend that we are here and we are trying to reach the bottom of the bowl. By using gradient descent, we randomly drop ourselves somewhere on our loss landscape. Now all we have to do is orient ourselves such that we are facing downhill and ride the slope until we finally reach the bottom of the bowl. But the problem is that it's not that simple for the system. The system can take parameters like theta 0 and theta 1 and compute loss function. So it can compute relative positions, but it has no idea which direction it should take steps and how big should the steps be to help it to get closer to the global minimum. Therefore, we use gradient descent to compare loss function in each step and tries to find a direction that can ride the slope and get close to the minimum. Imagine that we are here. Then we take a step to here. Now gradient descent starts to compute loss function for these two positions. After understanding that the new position has lower cost function, then it took a step to the new position. This process will be repeated until we get to the bottom. And because the slope is getting decreased, then each time our step will be smaller. For using gradient descent, we have to initialize our alpha parameter, which is our learning rate. Alpha determines how big should the steps be. Don't worry if you're a bit confused. You can email me and ask your questions. You will learn more details about gradient descent when we start to code. Next session, we will talk about overfit and underfit that are really important in machine learning and deep learning. If you haven't joined our channel, please subscribe and turn on the notification bell so whenever I publish a video, you will be notified. If you enjoyed this video, please like us. And if you have any idea to improve this course, type it in comment.